remind me to stop the camera when we're done? Okay. No, we're getting right after this. Getting right to the problems. You guys ready?
I never solved 6.
Yep. Sure. You can ask the question, I believe. Alright, we're going to get right to the problems. We're going to get into percent composition, empirical formula, molecular formula stuff that we did last year, or if you're Emily, 2 years ago. Okay, so this won't be new, or we will have a couple problems that will be more challenging than last year, but it should be still review. Are you seeing a theme here, which is kind of interesting, because this is a college level chemistry class. It is. I mean, pre-med school students have to take this class. Okay? So I mean, I know we're only a couple weeks in, but we're 3 chapters in, and there's been very little new stuff. The only thing that's been completely new are naming acids. Okay? And you're going to see that as a trend. Is it a little more difficult?
Yeah.
A little bit. Okay? But for the most part, same concept, same materials. Okay. There are 2 ways for describing the composition of a compound. We can describe it in terms of the atoms that it has, or in terms of its percent mass. So what we're going to start today with is we're going to start by doing percent mass. Now there are 2 ways that you might see percent mass, or you might be percent. One way that you could see is they could just give you a compound. They could give you, like in this case, C10H14O. And they could ask you to find percent mass. They just give you a compound, that is it. The second type is if they give you all of the atoms' masses. And I don't think necessarily one is easier than the other per se. You could say if they give you all the masses, it's easier. If they give you all the masses, all you need to do is part divided by whole. You're essentially just coming up with a percent, right? So if they give you 10 grams of carbon, 20 grams of oxygen, and 30 grams of hydrogen, you get the total, and take each part divided by the total, you got the percent, right? Okay, so I don't know if we're actually going to do any today where they give you masses actually. Okay, could they give you a total mass and 2 of the 3 parts and you would have to figure out what the 3rd part is? Yes. Okay, so I don't know, I can't say for sure if you won't have one of those in your homework, but we're not going to focus on if they give you all the masses because it's just part over whole. Cool? Alright, but before I do this problem, actually I'll probably have you do this problem, but I'm just going to give you a quick little demonstration of finding percent mass when you're given a formula. Okay, now we have talked about this quite a bit. What's unique and what allows us to do this is the simple fact that every compound has the same ratio of what? Atoms to each other, right? So no matter what, if I have this compound, no matter what the mass of carbon is, it better be a 2 to 5, 2 to 6 ratio of hydrogen. Okay? So if I got 20 grams of carbon, how many grams of oxygen would I have to have? What? 10 grams? If I got 20 grams of, wait.
Wait, what did you?
Oh, that was it. I said it's oxygen. So 2 to 1.
Oh, you said
10. Okay? So it would be a little bit difficult if I gave you the mass of the whole thing, but the point is I can scale those numbers up and I can scale those numbers down, but the ratio is always the same every single time. Okay? So we really technically don't need to know the exact amount of grams present to figure out mass percent, because it will be the same percent whether I got 100 grams of the whole thing, whether I got 5 million grams of the whole thing, it doesn't matter. The percent by mass will be the same because the number of moles will be the same, ratio-wise. Okay? So how do we go about doing this? Then we're going to take the number of moles and convert it to a mass, and then find percent mass. So how many moles of carbon do I have? How many moles of carbon do I have? 2 moles. Oh boy.
That was like.
How many moles of hydrogen do I have?
6.
I'm on the trickier one, I get it, because it's in 2 locations.
Oh, it's not
And how many? Okay.
16, 6.
Now we know the mole ratio. Every time I've got 2 carbons, I gotta have 6 hydrogen. Every time I got 2 carbons, I better have 1 oxygen. It's a set ratio. So shouldn't the mass also then be a set ratio? It will be a set ratio. It's not gonna be a whole number ratio. Okay, because I know that 2 moles of carbon always weighs a specific mass. Now, could these numbers go up and down? Yes, but the ratio between them will always be the same. Could mass numbers go up and down, but the ratio between them will always be the same? Okay? So we're going to take this, and we're going to convert them to a mass number. How would we do that?
Multiply by the atomic mass. Or, sorry, not the atomic mass, the molar mass.
For
Yeah.
every 1 mole of carbon, for every 1 mole of hydrogen. And I don't know if you have a spot to put this. You're going to have plenty of practice here in a sec. What do we got? 16. You guys got this memorized yet?
Yeah.
So essentially, I'm taking these mole ratios and turning them into a mass ratio. Got numbers for me? Or no? You want me to just do it for you?
24, 5.
Carbon, hydrogen, oxygen. Okay? Do we have the parts? The part of the mass? Do we know the mass parts?
Yes.
Can we figure out the total mass?
Yeah, just try.
You should divide.
By the total? Yeah.
Okay. Yes, we gotta get the total first. How do you get the total?
Oh, add.
Alright, take and add all those together. 46.08 grams. And then how would you finish? Part divided by whole times 100. There's your mass percent. Go ahead and do that. So essentially what we did is we started with a mole ratio, converted to mass to find mass percent. We're going to work backwards when we start figuring out empirical formula and molecular formula. We're going to take a percent and go in reverse. It's actually much more convenient for us, or much more useful for us to take a percent and find a formula than to just take a formula we already know and figure out the mass percent. Okay, but we got to start the forward direction. What do we get for percent of carbon? 52.14%. This is by mass, not by mole. Okay? How about hydrogen?
13.2.
I got 13.13. Close enough. Okay, and oxygen 34.73. Now, if you get 2 of the 3, could you figure out the third just by subtracting from the whole?
Yeah.
Okay. All right, I want you guys to do the next one quickly on your own. Done. I mean, yeah. I just want to make sure that you can do it on your own. Raise your hand. Okay. The answers are compare with one another. Someone want to share the answers? Everybody say yes or no?
Sure. Carbon, 79.9%.
Yes?
Yes.
Everybody?
Hydrogen, 9.4%. Or something like that.
Yes? Okay?
Oxygen, 10.6%.
Yes?
Woo.
Is that a no?
There's a woo.
Okay, alright.
Right.
I realize, guys, this is pretty straightforward. I'm gonna get to here's a more difficult one. I don't think it's on your notes. Just absorb this, okay? Okay. Alright, so we want to figure out the formula of the compound. Here's what we've been given. The substance has been prepared that is composed of, we know that it has carbon in it, we know that it has hydrogen in it, and we know that it has nitrogen in it. Okay? We weighed it, and we know it has a mass of 0.1156. This would be the mass of the whole thing. Does that make sense? Okay? All right, let's say we react it with oxygen. Okay, we take and react this with oxygen. When we do this, we get 1.638 grams of CO2, and we get 0.176 grams of H2O. Figure out the formula of the compound. Sounds like fun. Just watch. This is a difficult one, and I just want you to walk through with me, okay? So, we know what makes up the compound. We don't know the formula of the compound. We know the mass, and we know that if we react it with something that's not in our original thing, we get certain masses of things we know. Okay? So we're going to use this information about the reaction with oxygen to try to deduce how much of what formed CO2 and how much of what formed H2O, how much of it was the stuff we originally had, how much of it was oxygen that was added. For example, if I can figure out how much oxygen was added, would I know how much carbon I had that made up that?
Yeah.
Okay, wouldn't that allow me to then probably get a percent mass and things like that? If I know how much oxygen was added, I can figure out how much hydrogen came from this. So essentially, the hydrogen that makes up this came from here. The carbon that makes up this came from here. Oxygen came from some outside source. Make sense? So it doesn't really necessarily matter where the oxygen came from.
Nitrogen is just whatever's left.
Yep. So let's start with this one. Here's our CO2. Is there any ratio that we could do that would allow us to get just the oxygen, or sorry, just the carbon mass out of this? Notice how we just have two things here. That's important.
It's 44.1 total. So that's total.
44.01 grams of CO2.
Yeah.
Would that cancel out grams of CO2 here? What's the relationship for every 44.01 grams of CO2? What's the relationship carbon to that?
12.01.
Do you see how we know that if I have this much CO2, I better have this much carbon? Now, we don't have that much. We've got to figure out how much carbon we have if we have a lot less CO2. But is the ratio going to be the same? Yes. Okay, so grams of CO2 will go bye-bye. When you plug this into your calculator, you should get a small mass of carbon.
Sorry, 0.0447.
Now, this came from this. So you see we have a part and we have a whole. Let's do it for hydrogen. We're going to use the H2O guy.
Where'd you get the 44?
That's the molar mass of the whole thing.
So that's
Carbon dioxide.
So this is the relationship carbon for every whole thing.
It's
Yep.
16 plus 68 plus
Yeah.
12.1.
Yep. So what do we got? 1,676 of H2O.
Yeah.
Same idea here. We know it's 18.02, correct?
Yeah.
And hydrogen would be, and we can figure out how much hydrogen we got from our original sample. Now we are assuming that this thing is reacting to completion. If it didn't react to completion, we'd have a problem. But we're going to make that assumption. Okay, what do we get?
0.0188.
0.018, close up 5, because it's like halfway. Hydrogen? Okay. How would we be able to find nitrogen? Add these two, subtract it from that. Okay, when you do that, actually let's just do this. Why don't we give percent first? Because we'll just subtract it from 100. Okay, so this divided by whole. This divided by whole should give us percent carbon and percent hydrogen. For the sake of time, I'll just give it to you 38.67.
Yeah.
So percent. Hydrogen, 16.22. And add those two together to get, and subtract from 100 to get percent nitrogen. Everyone following the mindset or process of figuring that out? 45.11. All right, so this is essentially what we just did, find percent mass, but it was a more difficult way of doing it. We're gonna go a step further and try to figure out the empirical formula from this percent mass. Something that's gonna be a little bit different, but still review from last year. We're still on the same problem, just gonna determine the formula here. Let's start with this. Now, this is the percent mass relationship between all of this. Would the ratio be the same if I had 100 grams, if I had 1 gram, if I had 0.0001 gram? Would it still be the same ratio of all of these guys?
Yeah.
So which one would be the easiest to assume this is out of? 100. Okay, so it doesn't matter. You could try 2 grams or 5 grams, but use the easy one. Let's assume this is out of 100 grams, which tells me that I have how many grams of carbon?
3.21.
That's not carbon.
3.22.
Okay, and 16.2.
You're out.
You erase hydrogen in the
You just divided them by the molar mass.
What'd you say?
I said we'd be getting a lot of J hours right now.
I make a lot of mistakes, that's why I can't do it. I already make too little here, so I gotta make sure I can't just keep it like candy. All right. Let's convert this back to moles, because when we find chemical formulas, aren't they in a mole ratio?
Yeah.
Like H2O is a mole ratio, correct? Okay, so let's take this and go back just like we did, but the opposite to find percent. Okay, instead of plugging all these in, can I just give you the answers for sake of time here?
Yeah, 3.22.
Okay?
16 pound flat. I memorized 14.01.
Yeah, 14.
I think that's right.
Yeah, that's right.
Okay. Now these aren't nice whole numbers, are they? But we know formulas are always nice whole numbers. So what can we do with these guys that would give us nice whole numbers?
Multiply them by 100.
That's true.
And then simplify.
No.
It would work.
We know that empirical formula, on your notes, I don't know if you guys remember, empirical formula is the smallest ratio. If that's the case, the smallest ratio usually means that we're going to have a 1 somewhere in here. So what can we do to get one of these to be a 1?
Divided by 3.22.
So what you do, but we have to do the same thing to all of them because this is the correct ratio, right? It's just not a nice whole number. Take everything and divide it by the smallest number. Will that maintain the ratio? Just give me nice whole numbers.
1. I don't know what that
4.5.
is. 5. H5.
It should be 4.5.
It's 4.996.
Okay, what does that sound like? 4.99? So my empirical formula, CH5N. Now, is that empirical formula? Is that necessarily the molecular formula? No. Empirical formula is the simplest whole number ratio. The actual molecular formula will be some multiple of that, or it could be the same. Depends. Okay? And in a sec, I'll show you how to figure out molecular formula. And wow, time has flown. That was a tough problem. Okay, so this would be empirical formula. Okay, let's do one problem where it does it all, and we'll end with that. Actually, shoot. Oh, no, that's stuff. Let's do the white powder one. Look at that.
Okay.
Okay, because this one is going to encompass all of the parts that you are going to have to potentially see. And the other ones are just more examples of the same thing. That's not it. That's it? Okay. So this one, start with the percent. So the one before that is a percent where you had to find empirical formula. This one's a percent where you got to find empirical and then the molecular. Okay, so this covers all of it. Okay, a white powder is analyzed. It's got a certain percent mass of each of these. Okay, what can we assume, again, to start this process? We have percents, we're going to assume what? Out of 100 grams of the total, which is going to take that percent and do what with it? It's just going to give us a mass, right? What did you say?
Sorry, I told you about. I'd love to add the percent numbers that are making decimals, so it's way too big.
Okay, we can find the empirical formula here by taking this and turning it into the the mole ratio. How do we do it? Molar mass. Moles, 3.52 moles. Now again, is this a nice whole number ratio? No, but this is the correct ratio, it's just not nice whole number ratio. So how do we get nice whole number ratios? Divide by the smallest, so that's just going to be 1. All right. This is not going to give us a nice pretty number. What does it give us? Anyone know? Two point what? About 2.5, right? So, what do we do if it doesn't give us a nice whole number when we do this? Anyone remember? Multiply by a multiple that will give me a whole number. But you gotta do it to both, right? You can't just do it to one. So I know my empirical formula is P2O5. Is it possible to have an empirical formula where you don't have a 1? Yes. Here's an example. This would be the simplest ratio. Can't spell here, so I'm not going to waste time. Now, how do we figure out if this is the molecular? Anybody remember? This is the last step, and we've covered everything. We just didn't get as many examples as I would have liked. Anybody?
I remember this song.
What did they give us?
Oh,
They gave us the molar mass of the whole thing, the actual molecular formula. Well, let's get the molar mass of this and see if it's the same.
Oh, yeah.
Because if this is the correct molecular formula, won't the molar mass of this agree with this? I'm just going to give it to you. 141 point, just for time, 94. Is that the same? But we know it's a whole number ratio of it. It's the right ratio, just not the right numbers. So take that times 2, and we should get 183.88, which means this is the empirical, and the actual molecular formula, or the correct formula, is what? Questions? That is all of the material. We got through it all. We just didn't get all of the problems tonight.